and post it to YouTube. And if you miss anything, and you can revisit, and that also can be even used for the future. So, um, saying that, then we just start. Uh, Visual Slope is geotechnical software, as Dr. Frost just mentioned. And today we will focus uh, on your class, what you need to use in your class. And if you have a future questions and during your class, you can always email me and ask me questions. And when you email, I hope you can attach the input file so I will know what you needed to do. My email address is listed here, so you can always email me. All right. Today we will focus on uh, three things. First one is our just introduction of Visual Slope. What's the feature for Visual Slope? Then how do we do the model for Visual Slope? And finally, how do we perform analysis? So these are three things we will do. The features of Visual Slope. Currently, we have 12 modules, and actually we are just will soon have some updates, but not related to what your immediate needs. We have 12 modules. Most is slope stability analysis, soil netting design, retaining pile design, MSE wall design, reinforced slope design, gravity retaining wall design, seepage analysis, shoring design, tunnel lining design, freezing construction design, pile support embankment design, finally 2D FEM. Those in red, we may discuss it today. For 2D FEM, if I will have time, I will discuss. Otherwise, I will just omit that part. But we will focus on the three modules: slope stability analysis, soil netting design, and the reinforced slope design. But as I mentioned, if you have any other needs, very welcome. You can send me email, and I will give you help. All right. First, let's do for how do we do visual slope modeling? Because whenever we do analysis, different software like Financial Element, or you first need to set up model, then you can use this model for analysis. Visual Slope is very similar to those type of a program. So for the modeling method, we have 4 different type of methods. First is drawing method. You can just draw the model and then you can run the analysis. Second one is use AutoCAD import method. If you have an AutoCAD file, you can import into Visual Slope and then do some corrections, and then you can use that as model. And also tracing model, tracing method. If you have like a picture, you can just trace the picture to make a model. The last one is generating methods. For some instance, the model is a little bit difficult. Draw will take a very long time, so you can generate that. But today we will mainly focus on the first 2 methods, drawing methods and AutoCAD input method. So now let's just go to a specific model. Say this is a model, a Visual Slope model. Assume we need to do a slope stability on this slope, and this slope contains 2 different type of soil. The green one, we say it's hard clay, and the brown is shell, and you can have a more complicated model, but this is just a typical one, and if you know how to do this, you also know how to do the others. And we also, when we do the modeling, we commonly will do several steps. First, we need to define the range of the model, which is based on the dimension of the model. We give the horizontal range. For instance, for this one, the horizontal start from 0 to 120 feet. The vertical start from 100 to 180. And this is, you need to give a range. However, this range can be changed anytime with the change of the model size. So it just gives an initial range. Second, before we doing any model, we always want to set up the material properties, like soil properties. If we have other material like geosynthetic soil nails, we always want to give the material property first so we can use it during the modeling. So material property. For this case, we have two different type of soil, so we need to get the soil property set up first. Okay, so 3 steps. 1, we defined the range. Second, set up material properties. Then we can start to draw a model, and then we assign the material to the model, and then we can run analysis. Okay, so these are the steps we will go. So we just use this as an example. I show you step by step how do we do that. Okay. Also, when we draw, we should know the coordinates of each point. And so we will know exactly where to draw. So these are all the conditions we need. Okay. So now let's just go into visual slope. When we open visual slope, you can, I already sent the download the link to Dr. Frost. He will pass to you, and also there's a passcode you can activate the program. So when the open, it will have a file selection page show up. If you have a project you already worked on, most likely it will list in this table. So you can select one and then you can open up. If it's not listed in this table, you can browse to where the file is saved. But if you haven't done a project, you just want to start it. So we just choose new project. So you click new project, then you click OK. So the next page popped up would be the setting page. In the setting page, the first 2 lines, you can set the project name and then the subtitle in the second line. So let's just say this is example 1. We'll just say example 1. You can put this into it. Then to save time, I just leave it blank. Next one is choose the unit you want to use. By default, it will be meters and kilonewtons. But let's just say we use the foot and pounds for this project. Okay, so as far as the unit is consistent, there shouldn't be no problem. You can pick up any unit you want to. So now we need to decide the range of the analysis. we just mentioned the horizontal from left to right. Left was 0, right is 120. And the bottom, we said 100. And at the top, we say 180, 160. It really does not matter. And you choose the range. As I mentioned, if this range need to be modified later, you can always come back to change it. And most likely, you do not even need to go back to change that. So once you finish the range can be any number, can be negative, positive, but the only thing you need to follow is the left should be less than the right. The bottom should be less than the top, but you can use negative, it is fine. Okay. Once you finish that, we click OK. So now you're going to the main page of Visual Slope. So before I start modeling, I would just say, if you miss something I said today, you can always go to Help. In Help, there's a menu. You can click it, and the menu will show up. You can read the menu. And also, there's a video, lots of videos, and like a modeling by drawing method, modeling by AutoCAD. These are all what I would discuss today. So you missed those, you just click on that. It will take you to YouTube, and you can watch those videos yourself. Okay. So I just let you know you can always get help from there. And also you can go to visualslope.com. There's a tutorial page, and you can also have the videos from there. So either way, you should get help. All right, so now let's start modeling. In the first step, we already set up the range. Next one, we need to set up material. So we go to material menu, click on material, and there are different material tray there, but since we have not set up any material properties, they are all empty now. So to set that up, we click the material button. Okay, so the material page will come. And in that page, we choose soil material, because for this problem, we just have soil. So, so we choose new because we don't have anything yet. We choose new, then the setup page will show up. First, we give the soil name, say it's hard clay. Name, and the density, say it's 115. It's a natural density, and the saturated density, say it's 120. Collision is that. Collision is 300, and those numbers are just for this example. You should use whatever the number you will have. Okay, so for slope stability analysis, basically we just need these 4 numbers. Since we have a finite element, which can also be used for slope stability analysis, just in case we just need to set up some other data, which is elastic modulus and Poisson's ratio. So let me just give some number just for the sake of calculation. Just say 1 times 10 to 5 Oh, I'm sorry. Here I put like not really one there. And the Poisson's ratio, which is say 0.3. So once we have those numbers, we close this, then you will see hard clay is under this list. So when you click it, the color of this material is green. So next one, we say it is shale. Shale, and the density is 130. The is the same, and the cohesion is 2000, and the friction angle is 0. And the same thing, if you want to use finite element, and you should give the elastic modules. I just made this up, say it's 10 to 6, and Poisson's ratio is 0.25. So you have this. Okay, so we have a shale. Shale is brown. And if you do not like this color, you can always change it. You can pick up the color you want to and then click OK. Then the color will be what you choose. Okay. And also, I will tell you there's called material bank. Material bank is like if you have these two materials you already set up, you want to save it for your next project, you can always choose it and then click this button. So the hard clay will go into the bank. Then you can use it for next time. For example, I want to pick up something from the bank for this project. You can also choose from here and click it. It will come to current project. So this is a database you can always use. Okay, so I do not have that. I want to delete it, and you can delete this. So once you finish material setup, you close it. You will see in the soil tray we have two materials. Okay, and once you move the cursor to there, it will tell you what is the material name, and the new feature is if you double click it, it will allow you to edit it. You can change it, then you close it, it will change. Okay, so we have the material. Also, you can always go back to material and it's okay. I do have these. So once you choose soil, you will have you can do it there to make edit. But the easy way you can double click these. So this is the new feature there you can use. With the material, then we can start to draw the model. The model is consists of lines. The lines represent different things. Soil lines represent soil. If a water line represents water, so on and so forth. So let's just go to model. Okay. Let's first do the soil. And the first point, we pick up the line. This is the soil line. And once we move the cursor, you will see on the top ruler there is a red hair line. It's moving with the cursor, tells you where the horizontal coordinate is. The same thing for the vertical. I don't know if you can see it clearly. There's also a red line moving up and down, and you can see the position of the cursor. Also, at the lower left corner, there's a display. It will tell you the coordinates of the cursor. So these are the things you can find the position of the cursor. For the first one, I want to start from horizontal coordinate 20 and the vertical 120. So I would just go say I would just go here 20 and 120 just roughly. I just here I click it, and then the line stop. And then you can just use the display to find the coordinate, but that is not that accurate. So I want to be more accurate. The next point is should be 40 and 120. So I can just type 40 and make a space and 120. You can see in the yellow box the two numbers, 40 and 120. Once you finish these two numbers, you hit enter. So this point actually is 40 and 120. Okay. So, and the next one, I will do the same thing, 160 and 145, and you can do that. Oh, did I do? Uh, oh, I was wrong because there's no 160 in the horizontal, so it won't give you. Actually, it's 60 and 140. So once you do that, it will give you the line. And so by this method, you can very accurate pinpoint each point. Then I would just draw it. If you want to draw a horizontal or vertical line, you can click this orthogonal lines. So since I would have a horizontal line next to one, I just go this and go that. I do not even care what the coordinate is. And once you want to finish this line, you can click the right button of the mouse, or you hit escape key. So it will stop drawing. And I will continue to finish the model. So once you close to a point, it will snap on. So this one is something like that. And I do not want it to be perpendicular, so I would just go something like that. But so I have almost a model, but the numbers are not quite exact. So you can do just to type in stuff point by point. I would just draw that, and I can edit it. You choose this arrow and hit this point, and it will give you the coordinate. But for the first one, I just I very roughly choose number. It's not actually the one I wanted, so I just added it. When you close, it becomes this. This one was a right point. This one was 2, but this one was not. So I would change that. This one should be 60 and 120. So this will be this one, and this one would be should be 80 and 145. So this is suppose the number, and the last one too. I did not give a right number. It should be 105. 5. So these are the right one. After that, we need put a boundary line around, and you can draw it just you do for this line, but you also use a quick boundary. You can use a quick boundary. It will set up the boundary for you. Okay, so now I already almost finished the model, but someone will say, well, everything seemed to move smoothly, but what about I made a mistake? I want to edit the line. I want to delete the line. How do I do that? So let's just do edit. You can just choose this one. You already know how to edit a point because let's like say once you click the point, the number will show. So, but if I want to edit the line, you can choose the line, then this line will come and it will tell you what the line type is and what's the coordinate, the start and the end point. Okay, so you can change it there. You can also delete it if you want to delete it. Did I? Oh, I didn't uh, click the confirm, so it did not delete. So once we delete, we can delete and we'll say okay, so it will be gone. And if you want to redo it, it will come back. Okay, so these are how do you do the edit. You can also use this called multiple selection. You can just say, I want to select these two lines, this line, then you use the right mouse button to click, then it will give you options to say, um, you can edit the line, you can delete lines, you can deactivate the lines, you can activate the lines. So let's just say what called deactivate. Once you deactivate, these lines are still here, but they are not being used in the analysis. So that's called deactivate. Say you have a slope. Initially, slope is like that. You want to run the slope stability analysis. The later you want to fill this area and then run the slope stability again. So you can draw the whole model. The first deactivate these two lines, run the slope stability, then you reactivate those. If I want to reactivate these lines, say I activate lines, so they will be activated. So these are the model. After model has been set up, you can continue to draw. Say if you want to draw a surcharge, and you can draw a surcharge. This is the surcharge you already draw. If you want to give the intensity of the surcharge, you click on it and choose load. And let's say this is just say 115, 150. So that will be the surcharge. Okay. And you can also draw water lines. Say I have a water table from here. Then you can type the coordinate in, so they will be accurate. But for just for showing, I just say this is the water table. So this is the water table. So we have the line, we have everything. Then we fill the material, just a single click and then move the material to the area you want to be. Click it, and this area is hot clay. And the same thing here. This area is ship. So we have the model all set up. And before we lose it, we can always save it. Just the example. Example 1-1. So make sure we will not lose it. So during the modeling process, we need to remember the line must be connect point to point, not line. This is a point, but to the middle of another line. Otherwise, it will have an error. But the Visual Studio, most likely, if you put it in the middle of somewhere, it will automatically break it into two lines. So, but we need to remember these should be connected to point. All right. And also, when you draw a line, it should be, this is start point, this is the end point. The horizontal coordinate the start point of the horizontal coordinate of the start point should be less or equal to the end point, the horizontal coordinate of end point. So, which means it can be going this way or even vertical, but you cannot going like that way. If you draw a line in this direction, what you have to do is you draw this point first, and then come to here. So that's the rule of model. Okay, so this basically we finished the model, and I would just give you some features of visual slope. We already mentioned that this arrow is let you select a point or a line. This is a group selection, and this is a zoom in. Say if there's some place you want to see more clear, you can zoom in. It will be amplified, and you can also zoom out. And you can also use your mouse wheel to zoom in and zoom out. If you push up, it will go bigger, and if you just roll back, it will go smaller. So if, like say, your range initially was not set large enough, you can always use the zoom out rule to make the model smaller, so you can accommodate more area. Otherwise, you can make it bigger, so the model would not just in at the corner of some place. So make it more clear for yourself. Okay. You can also move this upward or any direction you want to. So this is what you have. You can move it. And if you did something wrong, you want to undo, you can undo. And also, this is called a flip feature. When we do slope stability analysis in visual slope, the slope must face left. I just mentioned, then you won't forget. Otherwise, say next time, why my model does not work? It must face left. But sometimes, if the model initially was face right, what you can do is you can just use this flip feature. It will flip for you. For the say this is original model, you want to do a slope, so you can flip it back. So these are the features of visual slope modeling. So basically, these are that. Okay. We spent already quite a bit of time for the first one. The second one, I would go a little bit fast. I don't know if you will actually use. So for example, if we have a model, something like this, and we already have the file as AutoCAD, and AutoCAD file is looks like this, and we want to import it from AutoCAD to Visual Slope. So what you need to do is you need to save this file into the DXF file, and should be DXF 2000 or earlier. So if AutoCAD can always save it to the early version, and you save it. So what we can do is, say if we have this file we want to input into Visual Slope. Let's just one. We'll just cancel that. I need to set up. And first, actually, it does not matter what kind of range you choose. So let's input a DXF file. Here is DXF in. We click this, and we have this DXF file here, and we click it. Okay, it comes. All right. It is when it comes, it will ignore all these hedge, and also the line is all considered as a soil line, and so it cannot distinguish it's a water line or something else. So we need to do some editing. So before we do, we need turn these two off, especially this one. This one is a connect feature. Say if you have a two soil line, they are cross to each other. With this connection feature, when you save it, it will automatically break these two lines so that they will connect at the point, not in the middle of the line. So let's not, because some are not soil line there, some are water lines. So we let's just turn this feature off for now, and we go here and zoom in because it's so small. So we zoom it in. So this will be the model we will have. And first thing, we need to convert the line to the correct ones. So let's just convert these three lines into water lines. So what we do is click, choose these lines, and use the right mouse button, and this action page will show, and it will say these are the water lines. So if we want to change line type, you say yes. Okay, so these will be water lines, and those will be boundary lines. We can do the same thing. Boundary lines. Okay, we choose boundary. Okay, so these will be boundary lines. And we will find these 2 points actually are not actually connected. So we want to put them together. So we connect these two, and what we do is highlight this and right click the mouse, say connect the points. Say yes. So the line will be connected. Okay, so by doing this, the model is kind of taking the shape. And the next one, we need to set up material. So we go to the material again, and we do not have any soil material there. But I'm not going to add a new one each time. I just get some from the bank. So I have 4 materials already saved there. So now we have 4 of them, and then you can just assign it to the place you need it to. So now we have a complete model. And, this is the way how do you use AutoCAD file to input into Visual Slope. But I encourage you just to draw it directly from Visual Slope. Sometimes there are some errors in AutoCAD you may not even know. Like if there are 2 lines, they are overlaid together, you cannot tell there are 2 lines. Then you won't be able to assign the material to it because it tried to find a closed sector, but you have 2 lines together. The program finds some error there, and it won't let you go. But you cannot, by your eye, you cannot really see their overlay. So I encourage you just to draw it yourself. These are the modeling process. We discussed drawing method and AutoCAD. Now we will discuss about the analysis for slope stability analysis. Okay, we have many features. We have circular, wedge, composite failure. You can use a different method for the analysis too. You can use the finite element method, Bishop, Yanbu, Spencer, Morgenstern, uh, LRFD, and all these features. So we just go with an example and see how do we do those different shape of failing surface and use different method to do the analysis. So we just go back. Let's open our example 1. This is the one we have just built. Now we want to do a slope stability analysis. We want to see how stable this piece will be. Once we brought the model back, we click on slope circular failure. Okay. So this is the circular failure analysis page. For the circular failure, when we do the analysis, we need to define an entry area and the exit area. The entry area, say we want the circle go from this area and going up, and the exit from some area on the top. That's what it needs. So you can type your range into it, but the more easily you can just click, say I want X1. You move the cursor to where, and then click it. And this point will drop to on the top of the slope, and then you can do the second one. Say here you drop 2. So these 2 green points will define the entry area. So the circles, the failing surface circles, will always start from always within this range. And then we can also define the exit area. Exit from here. So these 2 red points define the exit area. So we have these defined. And the next one, we need to give how many failing surface we want to try. Let's say just say 500. So we will 500 failing surfaces, and we want the circular type. And we can choose different method. Just say Bishop method. We just use Bishop method. And once we choose these and done, we click analysis, and it's complete. So you will see this is the factor of safety. The most critical one is 0.863. So once we click that, we will see this is the failing body. The bottom is a circular shape, and you can do the different ones, and you can see the different type. And these are the 6 most critical ones we have. And you can also do all of them. Say we know the lowest is 0.863, the highest factor safety is 3.81. So if we want to see all 500 of those, it will draw all 500 for you. Okay, well, okay. You can redraw it, it will show. You can also have a report for this analysis. So this is the report. You can print it, you can save it as a PDF file, and then if it's homework, you can turn it in. And you can also print the drawings. I want to print a failing surface. It will ask you, do you want to put the soil label on it? If you say yes, then you will have this with the soil name on it. So you can print that or save it as a PDF. Okay, so this is the circular failing. The circular failing, I just give a quick review. We need you need to have a entrance and exit area by these four numbers. Then you give how many you need for the analysis. And you can also choose different shapes, say just log spiral shape. And once it's done, it's the fact safety is even smaller. So this for the log, or you can have a different type. This is the irregular ones, something like this. So it depends on what you need. All right. Next one, I want to do like instead of a circular, I want to see what about this piece fell along this line. So what how do I do that? So what you can do is you use user defined failing surface. You click user defined. There's a point, and you click one of them, you will see a red button. This is the first point. The first point, it should be beyond the slope surface. Here, this is the first point. And then you can draw. This is that. No matter what type of shape you want to draw, I just want to draw around this line. And if this is the last point, we'll let it go beyond the slope too. So you will have this line. So once you finish this one, you can do analysis. Once you finish, it is 0.869. Yeah. So this is the failing surface C, because we just do one. But what about I want it search in a range, because it cannot be that narrow. It might be hit here, might be hit there. I want it search in a range around this line. So what I can do is, I want to do, say, I want to search 300 of those. And I want the search width be 2 feet. So once you finish that, you click it complete, and you will see that these are the boxes. Actually, the height of boxes is 2 feet. So this one will search along this line with the height of 2 feet. So you can do this, and you can find the next one and find some others. So once you see, if you want to see all of them, it actually is like to search within those boxes. So you can search that. This is the wedge, whatever shape you draw for the first line. If you want just a wedge, you draw a wedge, then there will be a wedge. So you can do that. So these are the different shape of the failing surface. And you can also choose, say, if you want to use finite element to do this analysis, choose finite element method, and you click on it, and it will automatically form a grid elements. Once it's finished, it will give you the number 2. You will see finite element actually is pretty close to what we have done use a different methods. So this is finite element 0.885. So you can do the different method. Same way you can choose a different one. Then we can also consider like a seismic condition. Say if we want to consider seismic condition, we click on seismic, and then say horizontal, peak horizontal is 2G. So we just type in 0.2. And after you finish, then you run analysis again. Oh, I was wrong. I use find element. It's okay. So it will be smaller. So you can use a different method. You just put this there. And sometimes if you think the failing surface strength is a little lower than original material, you can also do a reduction. Say, if I want to reduce the strength, say, before the friction reduction was 1, which means it's not reduced. So we say it's a 0.9, the friction is reduced to 90% of the original cohesion is 0.87. So once you put this there, and maybe just not do a seismic. Let's just see. Maybe do this. Use actually, final element is fine too. So it will be reduced to 0.785. So you can have those numbers. So these are the features for slope stability analysis. You can use a different shape and also different method to do it. Okay, so we are already 4:30. 1 hour. I just give a very quick for the soil nail and reinforced slope. I don't see it, but we have time. If we don't, you can always watch the video we have. Okay. Let's just open the file. So this is the one I put some nails in. For the soil nail, if there are 2 portions, one is now not grouted, the other one is grouted. So you can grout all the way too, but what you do, you can just draw that in, or you can use the array. I would just say, let's see, let me delete those. So I do not have those lines there. When we run a slope stability analysis, 0.9 something like this. So I want to stabilize it. So you can draw it in just like we draw for the model. But in that case, we just say we want to generate it. And once you choose generate, and you choose a nail, say nail 1, I will show you what nail 1 the material type is. The start elevation is 130, and the end elevation is 142, and the vertical is 6 feet, and the angle is 20 degree, and both are unbounded and bounded, both are 20 feet. So let's just say it. So we have the nail generating. You can draw it 1 by 1 too, but for faster, then you can just draw it, generate it. And once we finish that, we run a slope stability analysis again with nails. And I say no. Okay. Now it's 1.135, so it increased. Was before was 0.9 something, but after you put nails in, then you will have a higher factor of safety. So this is how do you do. The next one, which is the reinforced slope. The same example, and I just see how do you do that. And instead of use nail, but if it's a field sample, you can also add the geosynthetics into it to run that. The way you do is you can, let me just say. So the line will be gone. So when you run, it probably give you 0.9 something again. So instead of use a soil nail, if this is a fill slope, you can use geosynthetic to reinforce it. So of course, you have to, in the material, you will have a geosynthetic geogrid, say. You will put this in the name. It's a plastic, it's a sheet, you give a name, and the long-term allowable strength, and the reduction on friction between soil and the geosynthetic, and also collision. Let's just do it. And the front end, if it's a free, then you can put a 0. If it's a wrapped, you can put a 1. So it should be between the 1 and 0. So the end is all free. It's a fixed. It's fixed. So we close it, and then we go to generate. Let's generate that. We have a geogrid. Start elevation is 121. The end of elevation is 143, and the vertical space is 2 feet, and the length is 20 feet. So once you put this in, so the geogrid will be in, and again, you can run a slope stability analysis with these, and we have a 2.85, so it's very strong, and we should also run a direct sliding. Okay, it's a 3 something, so it's very strong. Direct sliding is the soil will slide over the geosynthetics. You can see different ones. The lowest is 3.27. So this is the how do you run a reinforced slope. So I will just very briefly discuss that. I think probably you won't be familiar with it, but give you some flavor. For the detail, you can always go into help and see the reinforced slope design. Let me just pick up this one.
This example shows how to use visual flow to perform analysis for reinforced slope design.
So, okay. Yeah, so you can always go to the help menu and find the one you need and watch on YouTube. So I would think probably the time is just should be okay. And now if you have any questions, please ask. Anyone? Well, if
yeah,
you
in the chat, this one.
Yeah, go ahead.
when I use phi EM, where do I look for deformations?
Okay, you can look for deformation too. Say I give you example, but with the previous analysis, you won't be able to see the deformation because it's only used a limited equilibrium method to do the slope stability analysis. However, if you really want to see the deformation, let me just show you. Just I did not have time to show how to use the fund element. We just put this model back. Say if we have a slope, original slope is the brown one, and we want to fill this up, and we want to know how much settlement due to the filling. So what we need to do is we can go to use this model, and we go to find an element, and we choose plane strain, and we just generate a mesh. Just use basic mesh. Okay, so the mesh is already generated, and to estimate the settlement due to soil fill, we need to first calculate the initial deformation of the soil, the brown material itself. Then we need to eliminate that because this happened long time ago. The only thing we are interested in is the settlement caused by this piece of soil. So what we do is we already set up the whole model, and we also have this the mesh generated. So what we can do is first we select these, and we say deactivate soil line. So this piece will be out. We want to take this piece out too. Deactivate non-soil line. So these two lines will be gone. We should also take it out, just to deactivate. Okay, just assume there's no. And once we finish that, we're going back to find the element. We click. So the reset is off. Reset, fine. First step. So we have the deformation, but this deformation we actually are not interested because it's caused by the brown material itself. So that's the first step. The second step, we go back and put these lines back. And also, okay, so then we run slope step, run find the element again. But I would reset the displacement because I do not want to include the previous displacement. So I click that, let it be reset. So once we reset, we click this again, and then you will see here, actually, if we want to see the deformation, say vertical deformation. You will see here is the actual vertical deformation because it's a rock and it's deformed very small. It's almost like it's like orange color. It's 10 to minus 2. It's less than an inch. But if you want to have a detailed number, you can draw a line here. So these are what is this line is the x coordinate, but the y should be the same. But this is the actual value for the settlement. You can copy that and paste it into a spreadsheet. You can have number. The same way you can also, for the horizontal deformation, you will see how much horizontal deformation would it be for the soil here. So that's the way you can evaluate deformation. Okay.
Okay. Thank you very much. Very nice work.
Okay. Any other questions? Okay. If not, let's just stop here. And in the future, you have questions, you are very welcome to email me. And when you email me, attach your file so I will know what you want to do. Or there's some error, I can correct that for you. All right. Thank you, everyone, and stay healthy and be responsible for yourself, also for your fellow students and teachers. Okay, bye.